Are you struggling to keep up with the demands of managing and securing identity in your distributed enterprise IT environment? You're not alone, but don't let it hold you back. With Strata's identity orchestration platform, you can secure all your apps on any cloud with any IDP, so your IT teams will never have to refactor for identity again. Imagine modernizing app identity in minutes instead of months, deploying passwordless on any tricky old app, and achieving business resilience with always-on identity, all from one lightweight and flexible platform. Want to see it in action? Share your identity challenge with us on a discovery call, and we'll hook you up with a complimentary pair of AirPods Pro. Don't miss out. Visit strata.io/cloudcast. That's strata.io/cloudcast.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And it is Aaron for Cloud News this week. It is hard to believe, but January is over. That also means our look-ahead shows are over. So we're going back to regular programming here. But before I go back to that, we're going to talk about Cloud News. I have 3 or 4 items this week that we're going to be talking about. First of all, this article is actually, a couple weeks old, but came to our attention recently. And it's all about the differences of SRE versus platform engineering versus DevOps. And with all the attention given to platform engineering here recently, lots of questions will come out. It's only natural. Lots of articles written to clarify those questions are coming out, and we're starting to definitely see those in force. I thought this article was very good. It's definitely worth a read. And quick summary of everything, though, is SRE teams really focused on applications and services and making sure they operate reliably. Platform engineers ensuring that the infrastructure on which these applications and services run operates seamlessly. And DevOps is always this kind of methodology and process that really wraps all of this together. So think of that and go read that article and take a look. And for our second article, what we're starting to see, this one and the next one, some of our predictions for 2023 from our show at the end of 2022 starting to come true already, which, hey, I mean, maybe we're getting better at this. Probably not, but maybe we are. But this article is from TechCrunch. This is a member-exclusive article. I don't have a membership, so you can only read the top couple here, but I wanted to highlight the idea behind the article. And this is something we're seeing VCs and momentum slowing in startups. And quite frankly, there's just too many unicorns. I've said more than once on Cloud News, unicorns are a dime a dozen. And if you go look at, there's approximately 1,200 companies at this point worth over $1 billion. And I mean, that's a bubble. And you're starting to see down rounds, and you're starting to see VC money starting to be harder to get in raising funding. And so this is probably only natural as we start to see a bit of a correction in 2023. And as I mentioned, the next news article also going into predictions. I'm not sure who said it, but we were talking about Twitter and the future of Twitter in our predictions. And we talked about, hey, what would stop because Twitter got rid of over half the company, what's going to start them from going and starting something better and lessons learned and going and getting some funding? Well, guess what? It happened. Spill has received a $2.75 million pre-seed round. This was just announced. And you can go and reserve your handle on the platform. And apparently over 60,000 people have already signed up. So this definitely has a good bit of buzz as this moves forward. And some may say, well, is it just a Twitter competitor? Kind of, sort of. The whole idea behind it is really it's a live news feed where people can post things, but it's designed to be more around this hybrid in between images and text. And also, by the way, at least in the initial looking at it. Doesn't seem to do too much with video, which, thankfully I'm kind of a bit concerned that all social media is going to video now, but this is something that, very low friction, seems something that, can be potentially a competitor to Twitter and something we'll definitely keep an eye on. For Cloud News, I'm going to wrap it up for this week, but I will admit there is another article. We're just out of time. There's another one in Cloud News, 8 tips for creating an API catalog and why you need one. This came from one of the newsletters that I subscribe to, and very, very good article if you're into API creation and catalogs and discovery. And so with that, I'm going to wrap up Cloud News for this week. And coming up right after the break, we have Josh Patterson talking about composable data analytics and Apache Arrow.
Today's show is sponsored by How to Fix the Internet, an original podcast from the Electronic Frontier Foundation. Sometimes it can feel like we are moving towards a digital future no one wants, but it doesn't have to be that way. There are choices we can make to create an internet that makes a better future for all of us. In each episode, Cindy Cohn and Jason Kelly invite someone with a vision on how to fix the internet, someone with real solutions on how to move the needle forward towards a better online world. We checked out the Freedom to Tinker episode of How to Fix the Internet, and it was interesting to see how we can learn from open source and lessons from the past to fix future challenges. Search for How to Fix the Internet in your podcast player, and we'll include a link in the show notes. Our thanks to How to Fix the Internet for their support. Today's sponsor is Datadog, a real-time monitoring platform that unifies metrics, logs, and distributed traces from your cloud containers and orchestration software. Datadog's container-centric monitoring features allow you to track the health and performance of your dynamic container environment. The container map provides a bird's-eye view of your container fleet, and the live container view searches, groups, and filters your containers with any criteria, like tags, pods, or workspaces. To start monitoring your container clusters, sign up for a free trial today, and Datadog will send you a free t-shirt. Visit datadog.com/container-cloudcast to get started. That's datadog.com/container-cloudcast.
And we're back, and it is just Aaron this week for our interview topic. And we've got a really, really interesting one. We've been digging into this idea of data analytics and more particularly what we're going to call composable data analytics. And for that, we went and found Josh Patterson, co-founder and CEO at Voltron Data. Josh, how are you doing, first of all? And give everyone a quick introduction as well.
Doing great. Thank you for having me on your show. Where do I begin? We started Voltron Data in 2021. Wes McKinney, Darren Haas, myself, and Rodrigo Aramburu. And we were on a mission to build a more modular, composable data ecosystem. And we have, just a very, diverse set of backgrounds. I came from NVIDIA prior to Voltron Data, where I spent nearly 5 years working on Apache Arrow. But through the lens of GPUs, how do we bring GPU acceleration to data analytics? And the same things that allow people to use Arrow across languages were some of the same reasons that it was great across silicon. And so we built out the Rapids ecosystem. And after several years of that, I was looking for my next thing in the continuation of more modular and composable systems, and it led me here.
Oh, fantastic. And yeah, your background, obviously very strong in data analytics, but tell everyone else as well. There's also, you did a Presidential Innovation Fellow. Tell everyone a little bit about that.
Absolutely. I haven't, or I'm not a military person yet. I never rule it out, but I'm not in the military, but I've, always had this kind of patriotic bone. And one of my mentors back in the day at Accenture Labs, she did a Presidential Innovation Fellowship. And I thought it was really neat to kind of take a year and give back to government and help them innovate across, a myriad of technological areas. And so I applied. I spent a year primarily with the Department of Commerce and the Census Bureau, just helping them think about, modernization, data, educating them on trends in big data, data processing systems, machine learning. We did a lot of research on gender equality and how a lot of the census data could be used to kind of glean more insights on what's going on within our country around salaries and what factors lead to some of the gender inequality. And it was a really great time. I encourage everyone to take a year away from their kind of normal scheduled career progression and just give back to the government. There's the Presidential Innovation Fellowship. There's 18F, and then kind of since then there's been several of these governmental programs where they bring in innovators and tech talent into government. And so I think there's maybe half a dozen of them now. And so there's a lot of ways for people to get involved with the U.S. government to help their technological evolution.
Fantastic. Yeah, it's a great opportunity, and certainly encourage everyone to check that out. Now, let's change topics just slightly. Before we dig into Voltron Data, we probably need to tell everyone about Apache Arrow and get everyone familiar with that. So, businesses and organizations, they tend to be really overwhelmed by data analytics and big data. And it could be many different reasons why. Everything from the volume of the data to the tools and kind of the tools being all over the board to sometimes a lack of just resources of a data scientist or practitioners. So, and on top of all of that, I feel like it's an industry that or an area of focus that there isn't a lot of standards yet. And so how do you gain valuable insights quickly or cheaply is, I feel like, a big problem. And is that, first of all, is that a correct statement? And then also give everyone an overview of Arrow and how it came to be and does it solve this problem?
Absolutely. So I will start with a personal story. Prior to doing a Presidential Innovation Fellowship, I was at Accenture Labs, and I was working in cybersecurity. And we were trying to build a modern defense system for real-time kind of threat detection. And so we were using Spark, Hadoop, Apache Kudu, Cassandra, DataStax Graph, specifically for our graph engine. And we were using a myriad of big data tools, all specialized in different parts of the big data stack to really kind of build a best of breed defense system. And the compute cluster to do things was growing. And we had this increasingly growing cluster that was literally just moving data between systems, kind of taking snapshots of data, reformatting it into other formats, moving it to other systems. And what we realized is it was really painful to constantly move data back and forth between these systems. If you want to use a graph engine, if you want to use an in-memory analytics tool, if you want to use all these different things, you spend a lot of time moving data and paying for this serialization, deserialization cost, which really adds up. It just over time just bogs down the efficiency of the cluster because you spend more and more time as a cluster grows in size. As well as when the cluster grows in complexity, moving data, serializing it and deserializing it. And so, it was pretty bad. And then it got really worse when we started adding in GPUs. So we're doing graph analytics and moving graph analytics from Spark GraphX to, at the time it was this company called Blaze Graph. Not to be confused with Blazing SQL. So Blaze Graph was a smaller GPU graph database company. And, they were doing PageRank in seconds. I mean, it was just blazing fast. The name was very appropriate at doing graph algorithms. But getting data into the system took significantly longer than actually running any graph algorithm. And so we realized as we went down this path of acceleration and using more complex systems, the data movement problem was going to be extremely large. And so around that time, Wes and Jacques Nadeau and others were saying, hey, we can do something better. And they started socializing the idea of Apache Arrow. we loved it. We thought it was going to be, the most amazing thing, coming to the data system ecosystem. And while Wes was laying the groundwork on Apache Arrow with Jacques, that's when we went to NVIDIA and really kind of focused on acceleration. And so to answer your question, with that long story, Arrow is meant to be this tool that makes it easier to build systems. It's a standard columnar representation of data. And so instead of every system having its own way of representing data, where you have to pay the serialization, deserialization cost, it says, hey, what if we have a standard way of doing this? And it originally started as this language agnostic toolkit for analytics. And it quickly became a language and hardware agnostic toolkit for representing data, both in memory, whether that's CPU memory or GPU memory, as well as on disk. And then it has standards for how to transport that data across different network configurations and different systems.
So is it safe to say then that Apache Arrow is almost like an abstraction layer? In that it greatly simplifies everything because the underlying guts, if you will, it really doesn't matter anymore. Is that a correct statement?
In some ways. And so, when you think of abstraction layers, you sometimes think of, how the user sees it is one way, but everyone can do something slightly different under the hood. It's an abstraction layer where under the hood, everything is the same. So the systems themselves, when they reach out for data, they understand the data layout, whether that's in Java or Python or Go or Rust, or, I think it's now close to a dozen languages. It standardizes what's under the hood. And so while users might want to interact with the data across different languages or systems or hardware, what's under the hood is a standardized format. And so, it's a slight inversion on what people think about of an abstraction layer.
I like that. Yeah. Reverse abstraction, if you will.
Exactly.
Nice. I like that. So Arrow has, there's a lot of companies out there that are using it. Companies our listeners will be familiar with, Snowflake, Netflix, Meta, Databricks, Google, Microsoft. There's a lot out there using this in some way, shape, or form. And our listeners are going to be familiar with like Snowflake and Databricks and their business models. But what makes Voltron different? And how are you building a company on top of OSS software effectively?
Oh, that's a great question. So first thing, I'm going to give a shout out to my legal team. It's Voltron Data. They make sure that I always remind people of that.
Yeah. Okay, absolutely. I can see how that can be problematic. So yes, correct.
So we have to say that the full thing, like a Tribe Called Quest.
Sure.
But yeah, so Voltron Data. One of the things that we're doing is we're actually working with almost half of the names that you listed, as well as companies like DataStax, a plethora of hedge funds, and other analytic software companies to help them build more modular and composable software that is anchored on Apache Arrow. And so how we make money as a business is helping people adopt these standards of Arrow. Databricks, they had a great article recently where they were talking about their new batch BI loader. And they said that, Apache Arrow has, already become the de facto standard for columnar data and is already used by a plethora of leading open source systems. We're still only scratching the surface of people who should be adopting Apache Arrow. Every cybersecurity company, IoT company, pharmaceutical company, you name the use case, there's, GeoParquet. Sorry, I jumped straight to GeoParquet as an example. Parquet is a on-disk representation. Parquet and Arrow have this kind of symbiotic coexistence where the Arrow C++ and the Parquet C++ are now, within the same Apache repo. And so, Apache Parquet has been extended for geospatial. We would love to see more geospatial systems using Apache Arrow. And so what are the inhibitors for people adopting Apache Arrow? And one of those inhibitors is just support, knowledge, marketing. It's a very interesting ecosystem. As the number of downloads grows, we're seeing less and less content about Apache Arrow in some ways, and more about how people are building things on top of Arrow. And so we really wanted to, kind of not slow down the growth of the community. And so we wanted to make sure that people knew that there was a company supporting it, evangelize about Arrow and all the use cases of Arrow, as well as extend the Arrow universe. And so not only do we work on Apache Arrow, we work on a lot of other open source projects that both are abstraction layers or inverse abstraction layers, depending on the project, that help make other parts of the data stack more modular and composable. One of those projects is IBIS, for instance. IBIS is a portable Python API where you can use one Python API similar to Pandas, but you can use it across data systems. It has dozens of backends, and the whole point of IBIS is to not have a compute engine attached to it, but to be able to instruct other compute engines, both local and distributed, how to do different operations using this standardized kind of resilient Python API. And so as a company, we're helping other companies adopt better standards, adopt better building blocks for building software. And so if everyone starts using these more modular and composable standards, we believe that the data ecosystem overall will improve.
Nice. And when you mention modularity and composability, the architect side of me kind of goes, okay, what exactly does that mean? Like, what is some use cases, or what are some deciding factors of where do you break things up, if you will? Like, where do those, if I use the Lego pieces analogy, right? Where does the little Lego bricks, where do they break into typically? And is it like at a microservices level, or is it specific functions? Like, tell me a little bit about that portion of everything.
That's a great question. I'll give a few examples. One is Rapids, the project that I worked on for years at NVIDIA. The world had numerous distributed execution engines, frameworks for doing data analytics, machine learning, graph analytics, the various components of data science. And so instead of building yet another framework, we said we were going to build these modular composable engines that could be plumbed into things like Spark and Dask, that will use the exact same APIs as Pandas, scikit-learn, GraphX, and we will allow people to just basically move their data onto the GPU without a copy and convert. You still need to copy it onto the GPU, but removing that convert step is really beneficial for performance. And this was enabled by Apache Arrow. The other libraries in the ecosystem that adopted Arrow allowed us the ability to connect to them very seamlessly. And so if you wanted to use Numba, for instance, a just-in-time compiler for Python that can execute on CPU and GPU and other hardware, I could have Numba code, and I could immediately just hand that code off to cuDF, and cuDF could hand that off to QML, and QML could hand that off to some type of inference engine, and the data would never leave the GPU. Without Arrow, every step I would have to copy and convert that data back to system memory, and then copy and convert it back to the GPU. And that round trip is very painful, and would just probably make the end-to-end time 20 to 30x worse. And so that's one example of how Arrow allowed people to compose better systems. And so in a way like your microservice, imagine if every tool in your microservice chain was Arrow in and Arrow out. Now, whether it used Arrow inside of that tool or not, if you know that Arrow is always the format of how you link together these systems, if I remove one component and put it back something else that's similar to it, that's like in functionality, but maybe completely new or different, I don't have to re-architect my ingress and egress of data, as long as everything adopts this Arrow standard. Another example is with IBIS. I'm a user. I'm doing some type of data manipulation, and I write some code on my laptop, and I'm targeting, a local, Postgres server that's running on my laptop, and then I want to run this analysis on a much larger set of data. So then I want to, just push all this data into BigQuery and run some type of analysis. Prior to something like IBIS, if for instance, Postgres had a Python API, their Python API wouldn't be the same as BigQuery's Python API. And the user would have to then go and either convert it to SQL or convert it to that other dialect of Python. And now I can literally just take that same IBIS code and target Postgres or target BigQuery or target Apache Impala. And I don't have to change my code, and it can execute on these other systems.
Nice. Okay. That's super helpful. And I'll kind of come back to open source standards for our next one here. So with Voltron Data, the idea behind it has been, how can you obviously move the company forward, but also move open source and open source standards in this area forward? And so how does exactly these standards move data analytics as an industry forward? Is this are we solving a process problem? Is this a data set problem? Is it a supply chain problem? Is it a tools problem? Like when we say it's, moving faster, what exactly are we moving faster?
It's different for different users. When you build standards, you solve a myriad of problems, and it allows people, and it's one of the great things about open source, it allows people to kind of meet you where they are and contribute based on their needs. And so sometimes standards allow the end-to-end time of a system to improve. Removing those SERDE calls, the serialization, deserialization, it just makes systems faster. How much faster? Well, somewhere between, a couple of percentage faster, maybe like 50, 60% faster, up to, in some cases, 10 to 15 times faster. And there's been a lot of, really great blogs written about this. Snowflake, Databricks, Streamlit had a really great blog about when they adopted Apache Arrow, how it, made their transport time, 15 times faster, and they deleted either 1,000 or 10,000 lines of code. I always, there's a off by a zero error here. But even deleting 1,000 lines of code is exciting. 10,000 is even more exciting. And so in some cases, these open standards allow less maintenance. In the case of Streamlit, not only do they have less maintenance, they got increased performance, and they got new features. And so when people have standards, if I care about a feature that you might not care about today, it doesn't mean you won't care about that feature in the future. And so when we kind of push all of these things into one standard community, standards-based community, it allows us to really kind of grow the functionality, the performance, the ease of use exponentially. And so we would have a much harder time bringing in GPU acceleration into data analytics if it wasn't for Apache Arrow. And so Rapids was, the first, kind of complete compute engine built on top of Apache Arrow. And so now you have polars and data fusion and, several others have emerged. DuckDB, works very seamlessly with Arrow data. And so there's this emergence of all these tools that are Arrow native now. And prior to this, they would just be other tools that would have to have these difficulties interacting with other data tools in your system. And some of this emergence of these standards allow other improvements happen as well, like Velox. And so Velox is an Arrow native engine, again similar to Rapids, where it's not a full framework. It is just an engine. And so you can use Velox and plumb it into things like Spark and Presto and other systems. And it's a C++ vectorized compute engine. And so it's a modular thing. It's not a full distributed system. It's not it doesn't have a kind of a typical front end that end users would expect, but it would allow people who are already using Spark to use their same front end, but now get more vectorized compute performance, and things get faster. And so standards allow us to really kind of break down these monolithic systems into smaller components that we can improve upon and evolve and connect to new systems, languages, hardware. And so it's really, it's about how do we improve efficiently. And I think that's the real power of standards in the community.
Fantastic. So, Josh, last question for you. And this is kind of a standard one we ask a lot of folks with topics that are maybe potentially new to some of our listeners. Data analytics, I would say, has a reputation for having a decently high barrier to entry at times. And so if our listeners are interested, whether it's Arrow or just big data or data analytics in general, how could they get started? What do you suggest for folks that are just getting started these days?
That's a great question. I went to UNC for undergrad and was an econ major, and always kind of did econometrics and analysis, forecasting, kind of machine learning for economic problems. And that quickly evolved over my career into just doing more generalized data analytics, data science, and to now where I'm just working on data analytic and data science systems. But it really is sometimes as simple as just getting started and analyzing data where you have interest. Learning SQL is never a bad thing. Python, I used to say start with pandas. Now I think IBIS is a really great tool to start with because it gives you that increased portability. So you don't have to worry about some of the performance of pandas when you do want to scale to larger data sets, and it's very similar. But really, it's kind of getting that inertia. And to get that inertia, you just have to start somewhere and have to start small. I have a good friend who is a physicist, and he works on some really interesting optic based problems. How do you see things very, very far away at very high accuracy? And he wants to move into data science and data analytics, and he just started writing code, started doing fun side projects, and is just evolving his career with his domain knowledge of what he knows, and just learning new tools in the data analytics system, and just pivoting his career. And so I don't have a great answer of how to get started besides doing. Just start learning new tools, start doing Kaggle competitions, and really just find opportunities to analyze data and to showcase that, and then to start looking for opportunities to do that more increasingly, in your current role until you can find a role that allows you to do it full time.
Yeah, fantastic. Thank you for that. And the other thing I would maybe add to that as well, from my experience, not necessarily in this area, but in ecosystems that have Apache projects in them, go get involved in the Apache projects. The Apache ecosystem, I feel like is very structured, and it's very structured for a reason. And that also really enables folks to kind of plug in where they want to plug in. So it takes a little doing, but I'm always, encouraging folks to, if you ever want to go get started on something and, have a day job, but you want to do something on the side, go figure out something like that. So, Josh, how can everyone either follow you, follow Apache Arrow, follow Voltron Data? Like, what do y'all have coming up, or what's an easy way for folks to find out more?
Great question. So Voltron Data, we regularly write blogs on Apache Arrow, IBIS, kind of the greater ecosystem of modular and composable data tools. So follow our blog. We have a conference coming up this spring, the Data Thread. It's the second edition. There's a YouTube page for the Data Thread that has all of our first Data Thread videos. Has 40 videos. It's getting a lot of traction. People are just stumbling upon it and learning about Apache Arrow, Arrow Flight, ADBC, all the cool things going on in the ecosystem. And just kind of follow the Apache projects as well. IBIS, Apache Arrow, Substrate, Velox. They all have blogs, kind of Twitter handles. There's a lot of information out there, and we try to kind of wrap a bow around it at the Data Thread. And our goal is hopefully to do this kind of twice a year to really just highlight and showcase all the great things going on in the Apache Arrow ecosystem and the greater data science ecosystem of modular and composable tools, and to make it easy for people to know about some of the new and cool upcoming things that are happening. And so definitely check out the Data Thread this spring, and then just continue to check out some of our blogs.
Fantastic. Well, Josh, thank you very much. I'm going to close out on that. Thank you very much for your time this week. And for everyone out there, thank you very much for listening. We certainly do appreciate it. And if you enjoy the show, please leave us a review if you're able to, where you get your podcasts, and also tell a friend. On behalf of Brian and myself, thanks everyone for listening this week, and we'll talk to everyone next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.